Okay, get your books open, put your phones away, and let's get going. So, area. Area is measured in square units. And the reason is because it's two-dimensional. Okay, it's two-dimensional. Volume is measured in cube units because volume is three-dimensional. So for three-dimensional, you're thinking about like a box. Okay, and inside that box, you could fill it up with air. Okay? Whereas this whiteboard is two-dimensional. It only has length and width, whereas a box has length, width, and depth. Okay? And of course, we live in a three-dimensional world, and you draw on a two-dimensional piece of paper. These formulas are on your data sheet. They're on the front page. So area formula for a triangle. This is going to be 1/2 base height. Okay, and you can find that on the front page of your data sheet. Okay, so when you're popping that into your calculator, what you can do is you can just take the base, multiply it by the height, and then hit divide by 2. And remember that we're talking about a perpendicular height. So let me just draw this for you. That was awful. Let me try that again. So you're looking for this height. That's what we're talking about. A dotted line typically with a right angle sign. That's what you're looking for. Why didn't that show up? Terrific. Okay, so what you can do is you can put the little h beside the vertical height. This guy here. That's h. And then this distance across, that's called the base. Formula for the rectangle, this one should be pretty straightforward. This is just length multiplied by width. And the formula for the circle, pi r squared. So I think all of this should be a review for you guys from junior high, like probably grade 7 level. So what happens is you have to use these two-dimensional area formulas for three-dimensional shapes for the surface area. Like if you look at this shape underneath, this is a pyramid. Okay, so you can highlight that word anywhere you want, pyramid. It's a pyramid because it doesn't have the exact same base above it. That's a prism. Okay, so this is a pyramid because it has this point at the top, which they call the apex. There are all types of pyramids. You could have a square-based pyramid. Look at the base. It looks like a square. You could have a rectangular-based pyramid. You could have an octagonal pyramid. You could have a pentagonal pyramid. But for us, it'll be squares and it'll be rectangles. Okay? So let's label this stuff. Here at the top, you have apex. This guy here on the right, this one here, we're going to call that one the slant height. Because, of course, it's on a slant. Now, that slant height, you're going to sketch in with your pen or your pencil what I've done here with this black triangle. That is a right angled triangle, and that slant height is a hypotenuse, but only for half the base's distance. See how this line only goes halfway across? So that would be some half distance for the base. We're going to be doing some Pythagorean theorem inside these pyramid questions to solve for the slant height. Because the slant height is the height for the two-dimensional triangle. So there's faces. There's triangular faces. There's 4 of them. There's the front, the back, the left, and the right. And because it's a square, all those faces are the same. And that slant height for the pyramid is the actual height for the two-dimensional triangle. The height of the pyramid is here. That's the height of the pyramid, which we just call height. That's the height. Some people call it apex height or pyramid height. That's the height. So this one is used for volume. The slant height, however, is used for surface area. Because surface area is like wrapping a present, a Christmas present, or painting a wall. That's surface area. Volume is space inside. Surface area is two-dimensional. When the base of the pyramid is a regular polygon, the triangular faces are congruent. That's all these examples. A regular polygon, what does it mean to be regular in geometry? Same size, same angle. So like a square, you know how a square has the same side lengths everywhere? And it also has 90 degrees in each corner? That's a regular polygon. Okay? So what does it mean to be regular? Each one of these is the same size and same angle in that base, and therefore each one of these faces is the same. Each one of those faces is the same. So if you could find out the area for one face, you would just have to times by how many there are. So we're going to do some sketches together, and we'll talk about the area, and then we'll do some questions. So we still have about another 20 minutes of me up at the front, so please just bear with me, and then I will show you some homework, and then you guys can be more active and engaged, and I'll walk around and help. But for about 20 minutes, we got to get through this. All right, so surface area for a pyramid. Surface area for a pyramid is going to be the sum of the areas of each face. Remember, it's two-dimensional. It has square units. This lateral area is going to show up on your test. They're going to use this word lateral area. I'm not sure why they care so much about this. You're going to need to just memorize that for this test and then forget about it. The lateral area is the surface area of only the sides, not the bottom and not the top, if there is a top. Just the sides. So just memorize that for the test. There might be one question, a multiple choice, that says find the lateral area. I think it's there. Nevertheless, let's jump into what matters. We got a right cone. To draw a right cone, you draw the top part of a triangle, and then you just curve the bottom like this. And then for perspective, you can sketch in the top part of that circle the top curve like this. And then you will drop a right angle to the base and a radius to the edge. So this is R, this is H, this is S. H stands for, S stands for, R stands for radius. All right. The formula for the surface area of a cone will be pi r squared plus pi r s. If you look at that, it is on your data sheet. If you flip over to the back, just be aware of these formulas and where you can find them. And let's break down the formula. The first one, pi r squared. That is the formula for the circular base. Do you agree? What is a pi r squared? That's the area of a circle, so that's the bottom. Because what we're going to be doing is we're going to be putting these shapes together, and then you have to problem solve through the formulas. And you're like, oh, I don't need to paint the circle, so I can omit the pi r squared. That's what we're going to be doing. The pi rs, we call this the lateral, like we defined it up above, the lateral area. So we have the base area and we have the lateral area. Let's jump to the cylinder. The cylinder is also on this back page. You can find it to help you sketch. Typically it's done with an oval like that. Drop a couple parallel lines and then finish it off like this. So this is like a pop can or a can of soup. It has two circles. There's one on the bottom and there's one on the top. Those two circles are identical. They have the same radius. They have the same radius. And we call the vertical height, of course, just h, the height. The surface area from your formula sheet on the back page, this time you have 2 pi r squares. Why? Good, 2 circles. Plus, you have a 2 pi r h. Now this one, some of you might be able to decipher why it's 2 pi r h. I'll let you think about it for a second. What is 2 pi r? It's on your front sheet, 2 pi r. 2 pi r on the front page by the circle, what does that stand for? What is it? Circumference. And then you're going to multiply by height. So it's the circumference multiplied by the height. If you unraveled this soup can, the label, what shape would it make if you unraveled it? It would make a rectangle. And then you have like a length multiplied by a width, but the length is the circumference, which is 2 pi r. So that's where that comes from. And all these formulas, you guys, it's the surface area that's hard. The volumes, easy. The volumes are the best. The volumes you just pump in and you get out. It's the surface areas ones that you have to think about. So that's why we're going through them. All right, now the prism. Prism means that you have parallel base. Parallel bases. So you could have triangular prisms, you could have octagonal prisms, you could have all types of prisms, but we'll probably just have the rectangular prism, which is on your data sheet right at the top. That's the one we have. Now this one to draw, just draw a couple rectangles like this, like offset each other, two rectangles that are offset, and then just connect the edges. So we got the edges connecting up here to give the brain this illusion of 3 dimensions. So you have a left right, let's call that length. We got an in out, let's call that W, and we got an up down, let's call that H. So you have 3 dimensions, they're all perpendicular to each other, left, right, up, down, in, out. This is the 3 dimensions that we live in. Now if you look at that, how many faces are there? 6 faces. You got a front and a back, you got a top and a bottom, and you got a left side and a right side. So that's all you need to do to think of this. So surface area, top, bottom, plus left, right, plus front, back. I will color those for you. All right, let's do the top and the bottom. I'll color it for you. Do you agree that that's the top? Do you agree that the bottom is the exact same? Okay. What is the formula for the top? What do you have going this way? Length, and what about this one? Width. So we'll call that one LW, and there are 2 of them. Do you agree? Okay, let's do the left-right. Let's do this one in blue. What are the dimensions for this one? We got a width and we got a height. And there's 2 of them, do you agree? So we got 2 WHs. And then now we need what, the front and the back? Okay, let's do the front. What are the dimensions for the front? Length and height. And there's 2 of them, so 2 LHs. Guys feel okay about that? And the last one is the pyramid, and this one's just nasty. So for this one, we're going to do 2 pictures. One of them's the 3-dimensional, and then one of them's the net, the 2-dimensional net. So you can use the picture on your data sheet to help you, but I usually sort of draw like a slanted square. Let's just do a square. That didn't work out so good. Something like that. Sort of like a squished square. Find a middle point of that squished square. And then go straight up from that with a dotted line. Like this. And then you can connect that dotted line to the 4 corners. So boom, boom, 2 more, and there it is. So that one was not great because I kind of screwed it up. So maybe let's do something like this. Just so you can sort of visualize that pyramid's height. Now that's difficult to do. So what I recommend is that you actually just draw a net. So draw a square, and then just draw like 4 triangles like this. This one's way easier to visualize. And I would imagine like you're folding up those sides to make the pyramid. Let's just do the square version of this. So like, what's the area of the square? What's the area of a square? Let's call it S. The side has length S. What's the area of that square? Length times width, but they're the same. So S times S, that is called S square, right? That's the whole idea of squaring. It's just a square. And then you got 4 triangles, do you agree? And they're all the same because it's a square. So you have 4 area of the triangles. So S squared plus 4 multiplied by, what is the area of a triangle formula? From the front page. What is the area of a triangle? 1/2 the base times the height. So 1/2. The base of those triangles we called S. And what's the height of the triangle? Remember, it's 90 degrees to the base. If that folded up, this thing that's green, if that folded up, where would it be on the pyramid? This thing, right? And we call that the slant. So that was a terrible choice for S. You want to switch that out? Let's switch that out. Hopefully you brought a pencil. You can erase this. Let's not use S. Let's use B. And then we'll have a nice acronym there. This will be B. This will be B. So it'll be B squared, B squared. And then the area of the triangle will be BS. That'll be nice. BS. You guys okay with that? Maybe if it's silly like that, you'll remember it. BS. And we can simplify that if you like. What's 4 times 1/2? Good, it's half of 4 is 2, 2BS. So there's a simplified formula for the square-based pyramid. Square pyramid. Later in the notes, we'll do the rectangular pyramid, which is the one on your data sheet. This one is the toughest one. What I would do if this was a problem for myself, like I wouldn't even worry about this formula, the one that we just derived. I wouldn't even bother. What I would do if I was you is I would figure out the area of this square. Is that hard? No. I would figure out the area of one triangle. I would times it by 4, and then I would add everything up. I would keep things simple. I wouldn't try to memorize some derived formula. Okay, let's try this. Okay, so for question 1, you could follow a formula, or you could just think about it. I find that students that are just looking for formulas are the ones that end up with the most trouble. Those that want to actually think about it will find success. What is the shape on the bottom? Square or rectangle? Square. So each one of these is worth 8. Could you find the area of that base? How could you do that? It's base squared. 8 times 8 is 64. And the unit is a square centimeter. Square centimeter. Now the triangles, do you agree that they're all the same? Because they all have the same base, 8, and they all go to the same apex. Those slant heights are all the same, of 10. The area of a triangle is base multiplied by slant height divided by 2. So you have 8 multiplied by 10 divided by 2. That's 80 divided by 2, which is 40 square centimeters. But how many triangles are there? 4. That's the area for one triangle. Take that 40 and times it by 4. Because there's 4 triangles. That's why we times by 4. And you get 160 square centimeters. So the total surface area will be the sum of all the faces. So 64 plus 160, help me out, 224, very nice. 224, very nice. So this is what I would expect for the written response for the test. Show some work, solve it your way. If it's correct, it's correct. If it's not, it's not. There will be multiple solutions. Communicate your answer at the end. Be organized. Put a box around it. Make sure you have units. Question. You can go into the homework in your textbook. If you look on the very next page, you got the homework assignment at the bottom. You see that? Yeah. You can take out your textbook and you can start on that. Okay, now this one's a little bit more difficult. The young man who just told me that you're finished, if you have, as I go through, just make sure you got the same thing I got. Okay. All right, this one's a little bit more challenging, and I'm going to just actually draw a net for this. So draw a rectangle. Give yourself a lot of space around this rectangle. Make it large enough because there's going to be lots of notes on this diagram. So you'll have a triangle on that end, which is equivalent to the triangle on this end. And then you'll have a triangle on this end that's equivalent to the triangle on this end. It's a rectangular based pyramid. So make sure that you read carefully as you go through your math. Rectangular pyramid. It tells you that the base dimensions are 4 by 6. Make sure you understand that language. By, that's common English for the rectangular dimensions. So the 6 is the long end, the 4 is the short end. That's the rectangular 6 by 4. And then they tell you that the height is 8. So now what you can do is you can sort of sketch this three-dimensionally, which is no easy task. That was terrible. You can copy off of your data sheet to help you. That's what I'm going to do. I'm just copying off my data sheet. So they tell you that the height is 8. That's not a slant height, that's the actual height. So to calculate the surface area of the pyramid, I need slant heights, not that height of 8. So I need this one. So in order to do that, I got to create a right angled triangle and do Pythagorean theorem. Okay, so if this is 8, and remember we have You have 6 on the long end, 4 on the short end of that rectangle. We have to do a right angle triangle calculation for this slant. This is 8. This is slant 1. Yeah, this one's tough. This one's very tough. And 3. Why is it 3? Because it's half of 6. Notice it goes halfway. Okay, and then because we're quick on Pythagorean theorem, we can just do the shortcut 8 squared plus 3 squared. That was yesterday's lesson. That's why we put it in yesterday. You guys remember that? So this is 10c, okay? This is tough. 8 squared plus a 3 squared. And then you square root that. And I'm going to take about 3 decimal places for accuracy. Okay? Now we got to do it the other way. We need this triangle. So if I could sketch that triangle, this would be S2, the second slant. It still has the same height of H, but now instead of being half of 6, it's half of 4, which is 2. And then because we're quick on Pythagoras, this is not too bad. 8 squared plus 2 squared. I got 8.246. Okay? So those are the 2 slants on the 3-dimensional pyramid that I'm going to use for the 2-dimensional faces to calculate area of a triangle. Okay? So the slant for 6, that one's in blue. That one's 8.246. And the slant for 4, that was the red one. So that's why you got to stay organized. Do I remember which slant goes with which? The 8.54 is this one. And if you get that screwed up, your final answer will be wrong. The 4, base 4, goes with 8.544. And the base 6 goes with 8.246. So this is a tough one, and this one's going to be on your test for sure. But it'll be like one question in the written response. You still have the whole rest of the test to demonstrate your knowledge, so this one will be tough. If you can prepare for this one, then you can try to guarantee yourself 100. Lots of students in the AP class get 100. Occasionally, in the regular class, we get people who get 100, occasionally. So it's not out of the realm of possibility. Especially this first measurement test, it's not too bad. It's not too bad. The rest of the test you'll find is not too bad. So let's finish this off. Surface area will be 6 times 4. That's for the rectangular base. Plus, we do them 2 at a time. So you have 2 triangles that are base times height divided by 2. 6 times 8.246 divided by 2. Plus the other set of triangles of 2. There are 2 triangles that are 4 times 8.544 divided by 2. Okay, so this stuff here that I'll highlight for you, these 2 are both triangles. So you notice that you have a base times a height divided by 2. Base times a height divided by 2. And the 2's on the outside is because they come in pairs. There's 2 of them. A little bit of algebra, you'll notice that the 2's will cancel. That's nice. And then you can finish this off. 6 times 4 plus 6 times 8.246 plus 4 times 8.544. Final answer of about 107.7, roughly, meter square. Okay, so we saved the worst for last. Okay, that one's tough. Ian in.